Welcome back, students. Good morning. Today we are going to discuss the digital electronic class. As you all know that in digital electronics till now what we have discussed about the binaries, zeros and ones, and we took those combinations. We designed so many parameters based upon those zeros and ones. In today's class also we are going to continue the same topic. In these topics, we are going to cover some more examples based upon De Morgan's laws, based upon this Boolean laws and Boolean theorems. So, before going to start today's class, you need to keep in your mind the previous class, all the concepts. In the previous class, what we have discussed about the logic gates, we have discussed about the combination of binaries, that's the conversion from your binary one particular number system into another number systems. The next we have talked about the logic gates, form families, different types of it, special gates, your universal gates and the basic gates. So these things we covered in the previous classes. Likewise, we did some problem based upon those things, hardware and gate level designing. In today's class, we are going to see some more examples based upon it. So before going to today's class, take an overview what we have learned in the previous classes. That part we are going to see in today's class. So this Boolean algebra also we covered it. I just want to take the previous introduction, then we'll continue with our today's class topics. So this De Morgan's laws also we have discussed and theorems also we have seen. Next thing, we have seen the verification by using truth table also. So these types of problems we have seen, and these postulates also we have taken while we're doing the problem calculations. So likewise, we'll take a quick overview of it. What we have discussed: x plus 0 is x plus 1 would be 1, x plus x bar is also 1, x plus x is x double complement would be x itself. Then we have talked about this commutative law, a plus b is equals to b plus a. Then we talk about this associative law, a plus b plus c is equals to a plus b plus c. So here we are taking x plus y plus z is equals to x plus y then plus z. Likewise, we had talked about distributive law, a or x into y plus z can be written as xy plus xz. Likewise, we talk about this De Morgan theorems and the absorption theorem. So these things we covered in the previous class. So just a minute, we'll do some more problems based upon it. So how it is going to work, that part also we are going to cover it. So these theorems also we have seen the postulates and theorems also. So based now this number we just change it and we wrote it over here as a plus a. So now duality part also we have seen. Just I want to take you to the review of the previous class so that other coming numerical problems it will become easy for you while you're solving the problems. For that reason, you need to see what we have discussed and you need to keep on revising the concepts. So that's the reason we are going to see the duality. So what is the duality? Is X statement a plus b into c can be written as a plus b into a plus c. So these things also we just discussed in the previous class. So likewise, we have seen the problems like kind of concept which we have seen in the previous class, this one, or how can we change into and, then and how we can change into or by using this theorem, that is a plus b whole complement we can modify it into a complement into b complement. That means this or operator we are modifying into and operator. So that is also idempotence law we have seen. So next we are going to see this kind of theorem also, and we just prove also by using the chalk and talk method. That also I have taught you, just I have explained you this thing. Then we have seen this application part, how it is going to be used. That part also we covered in the previous class in detail wise. Likewise, in today's class we are going to cover these concepts also, like what we had, x plus xy is equals to x. This we need to prove it. For proving this thing, what we have taken, x as it is, x into 1. What is that 1 we are replacing with? Here x is common, we are taking 1 plus pi, again 1 plus pi is nothing but 1. So that we make it as 1 and we wrote it x. So this thing also we discovered and we talked. Now, in today's class, we are going to see these kind of questions and the conversion of those questions by using these all types of laws. So as you can see here, this question number 17. So this what is given, x of x plus y, we need to prove it as x. So this thing what we are doing, we are taking left hand side. In left hand side what we are doing, we are taking the number x of x plus y. So if you apply the distributive law, what is distributive law? A of b plus c can be written as, if you want to multiply with this, a with b we can do it, a with c we can do it, I can write a into b plus a into c. That only I have written. So x into x plus x into y. What is this x into x again? Will not write x square, will write x because it's a digit, it's a bit. So that's the reason it's become x. X plus this xy is as it is. So I can take x common in this. So x is as it is 1 plus y. So x as it is, what is 1 plus y? Again it is 1. So we prove it, x of x plus y is equals to x. So likewise we do have this question number 18. So question number 18 you see here. So what is the question over there? It's mentioned xy plus xy bar. We need to prove it as again x. For doing this thing what I have taken, xy as it is, this is xy bar is as it is, because this is left hand side. What is common in both? X is common. We left with y plus y bar. So we do have the formula. What is the first formula we do have? X plus x is x. X into x, again it is x. If you do have 1 plus x, it's become 1. Likewise, we do have y plus y bar or x plus x bar, it's equals to again 1. So by applying these all Boolean laws we are doing. So x we are taking common, we left with y plus y bar. So we got it as 1. So this is nothing but your right hand side. We did. Likewise, we do have the next question. This I'll explain you because it's a product term. So how the product term is there, that I'll show you on the board by writing and explaining. So this, see here 20 question. In this what is given, x plus x bar of y is equals to x plus y. We need to prove. For this thing we took left hand side, x plus x bar y. What is the formula we do have? A plus bc. This is called absorption law. So we discussed this also, absorption law. So what is absorption law is there? Plus term you want to write into product term. That is or term you want to write into and term. What we'll do? We'll add a plus b. Again we add a plus c. This way we wrote it. So that's point we are applying here. So a plus bc. So we multiplying x with first. So it is x plus x bar. We are adding and that is the first term by using absorption law. Then x we are multiplying with the next term, x plus y. So what is the value of x plus x bar? So we do have x plus x bar is 1. So that point we are writing as 1. We left with x plus y. That is your right hand side. So this is the way we'll apply, we'll do it. So let us see one more problem, one more example. We had x into x bar plus y. We need to prove it as x of y. For doing this we took left hand side. Again we multiply with both. What is the value of x into x bar? X into x bar is nothing but 0. So that we wrote it, x into x bar is 0, x plus y is as it is. So we left with xy, that is your right hand side. So this question, when they gave the number, so we need to prove it. So for proving this thing, I'll show here. So what is the question here? They gave x plus y bar. The question is x plus y bar. This is given. They asked to prove this as x. For proving this thing, what we'll do? This is our question. For doing this thing, we'll take first left hand side. So what is left hand side? We do have x plus y into x plus y bar. So what is the shortcut we can apply? Directly we do have the function a plus b into a plus c. So as you can see, this is similar to this part. This kind of question we do have this thing. X, here I can write a plus b into a plus c. So what I can write for this a plus b into a plus c? I can write a plus bc by using absorption law. So what I can write for this? I can write a plus bc. So here x and x both are same. So I can write once x plus what is left here? Y into y bar. Clear? So since this x and x both are same, so we are taking a plus b into a plus c. X is as it is plus y into y bar. So what is y into y bar? By using the first postulates, y into y bar I can write as x plus 0. So this is nothing but x. So this the way you can do it. What I have took x plus y bar. This is my left hand side. That I wrote it as it is. This I am applying absorption law. What is absorption law? A plus bc can be written as a plus b and a plus c. So this is in this form. I want to convert it in this form. So I wrote x plus y bar. So y bar is 0, x as it is. So that is nothing but x. So that is your right hand side. Clear? So this is the way you can do it, or else you can multiply x with first, x with second, then y with first, y with second. So that's what they did. X with x, x with y, then y with x, y with y. You did it. This x into x, again it will be x into y bar, it is as it is. Likewise we did that problem, or else shortcut way is that one. You can apply this thing, it will become easy for you to understand. So that's what they did this way. X as it is, x plus y bar, xy, y plus y bar is 0. So in this what I can take common? I can take x common in all. I took x as it is. Here left with 1 plus y bar plus y. So y plus y bar, what is the value of this? So you can see easily over here. So what is that left here? X into x we can write as x. X into y bar it will be xy bar. Then xy, y into y bar is 0. So in all these three terms, I can take one x common, that is as it is. Here left with 1, here y bar is there, here y is there. So this 1 plus y bar plus y. So what is the y plus y bar? It is again 1. This 1 plus 1, we'll write it as 1 only. That's for x into 1, it will become x. This is the way you can do problem based upon this De Morgan's laws and based upon the Boolean's laws. Let us see more concepts on this. This part also we covered in the previous class, how this De Morgan's postulates 1 and postulate 2, it is going to convert into the truth table. The verification part we covered in the previous class. Now, the most important topic, they'll definitely ask you for 10 marks question, solving the question based upon the Karnav Map or K Map. First thing, whatever the Boolean expression is there, till now we talk about algebraic manipulation. Algebraic manipulation in the sense, we talk about the truth table, we see the logic gates, by using logic gate we design, by using truth table we design, by using your theorems, that is De Morgan theorems and Boolean theorems and Boolean laws. By using these three concepts, these three come under your algebraic manipulation. Next concepts we are going to see, call it as Karnav Map or K Map. So this is nothing but simplification of Boolean expression can be achieved by using these two popular methods. There are a lot of methods are there, but among all, these two methods are quite popular and it will be very useful for designing the digital electronic logic families. So again, we'll do some more examples. So see here, these is the question. So here, what is the whole question is all about? This question is all about giving this thing, they asked to reduce the redundant bits or redundant terms or repeated bits or repeated term, or else they'll ask you convert this into very simplest form. So by using these laws, you need to convert the given expression as per the given condition. So for doing these things, what we'll do it? They gave a question, first thing, x bar y bar z plus x bar y z plus x y bar. So in this, we need to convert that function, that expression of Boolean function into the simplest form. So in order to do those things, what we are doing, we do have x bar, y bar, z here, x bar, y, z here. So what I can take, x bar z and x bar z are common in first two terms. So I am taking x bar z common. If I take x bar z common, what left here? Here left is y bar, here left with y. We got y bar plus y. This last term is as it is. What is y bar plus y? It is nothing but 1. So this is 1. So we got x bar y and xy bar. Can we take anything common in this? No, not possible, because here we do have x bar, here we do have x. So it is not possible to take anything common between these two. So we kept that term as it is. Further simplification is not possible. So that's the reason this whole, how many terms we do have, you can see 1, 2, 3. 3 terms is modified into 2 terms. With what are the literals? Literals are nothing but the variables. So here 3 variables are there, that will be modified into 2 variables. Hence we can conclude that function excuse me okay students, so second problem we do have xyz plus xyzw plus xz. So in this there are how many variables? So here we do have xyzw. That means it's a 4 variable or 4 bits. That is our first conclusion. Second thing, we need to check into anything we can take common. So what can we take common? xyz, I can take common. So I took xyz as it is. What left here? Here 1 is left, here w is left. So I left with 1 plus w. In the last term, we do have xz as it is. What is 1 plus x? So 1 plus x is nothing but, again it is 1. Okay, so that's point, we wrote it 1 plus w is nothing but 1. This is as it is. Again I can take xy common in this. No, xz we can take because we don't have any y term. So xz is common. Here y left here, here 1 is left out in that term. So 1 plus y, again it is 1. So we got it xz. So as you can see, these whole bit is modified into very smaller bit, that is xz. So likewise we do have next problem. Now the problem is in multiplication. So here z into y plus z is given, x plus y plus z is given. So to do these things, see, all terms are right now in POS form. What is this POF stands for? Product of sum. This P stands for product of, S stands for sum. So till now whatever we have seen, all are in sum of product form. What is that? That is called it as? That is called it as SOP. What is SOP stands for? Sum of product. How do we decide whether it is product of sum or sum of product? By looking into its term. So as you can see, they all are in multiplication. That means it's a product. Then internally that they are added. That's how we can conclude that this term is called product of sum. Whereas the previous one you can see, first addition is there. That addition is called sum. Then in internal part, like x bar into y bar into z. Likewise here, x into y into z. First addition is there, then multiplication is there. That's indicate addition means sum, multiplication is product. So sum of product, in short, they'll ask you SOP. So SOP is nothing but sum of product. So PO is nothing but product of sum. So this is one more name is given for this, is called max term, indicate by letter capital M, or they'll indicate by the letter, by the symbol pi. So this is very important. The product of sum and sum of product, they'll give in the questions. That is our next topic. Since it is covering here, it's coming here, so I'm giving a little bit idea of it. So here SOP, what is SOP stands for? Sum of product. It is one more name for that is mean term. It is indicated by the symbol sigma. So here we had the sigma indication and it is mean term. Here we had pi indication, that is nothing but max term. So now see the question here, z into y plus z, x plus y plus z. That what I did, multiply z with the first term, z with second term. So I got z into y, z into z. Here we do have x plus y plus z as it is. So what I can do it for this? I can multiply the term with this same thing. Just a minute. Sorry for the interruption. So here we continue with the third problem. So here we multiply z with the first z into y plus z into z. This is as it is. So z into y it's as it is. What is z into z? It is nothing but x into x. That is x. So here z into z can be written as z. So that term we are mentioning. So as you can see here, so here we are mentioning as it is. So we left with the same term. So here we'll got it z into y plus z as it is. This term, in this what I can take common, z I can take common. So I got it y plus 1. What is y plus 1? That is nothing but 1. So that's the point I am writing here, z. So as you can see here, so see here this problem what we did, z into y plus z, x plus y plus z we do have. So in this what we are taking, we are multiplying z with the both. So we got y into z plus, next z we are multiplying with z. So we got z into z. This we got it. Similarly, here we had x plus y plus z. So y into z, we cannot apply any kind of formula. So it is as it is. What is this z into z? That is nothing but x into x we can write as x. So by using this thing we can write here z. Clear? So here we can write x plus y plus z. Again in this term I can take z common. Z outside. Here we left with y plus 1. This will be left with x plus y plus z. So z as it is. What is 1 plus x? So 1 plus x I can write as 1. So here and this I can write 1 plus y I can write as 1. So we got with x plus y plus z. So z 1 is z as it is, x plus y plus z. So we can multiply z with this thing, or we can stop the term here. So that means this POS form we are converting into one single POS with z term. So this is how this problem is being solved. So completely this whole problem, when you want to see, it can ask you for 4 marks, so that you need to keep in your mind.